Okay, here we have a proof by induction, but we're trying to prove something related to three things: n plus 2, n plus 1, and n. So we need our first two initial values, which we've got here, which is fine. So we need to check. So let n equals 1. Let u1. We're trying to prove that un equals 3 times the power 1, take away 2 to the power 1, which equals 1, which is true. u2 is 3 to the power n, take away 2 to the power n, which is 5, which is also true. Okay, so true for n equals 1 and 2. Okay, so with true proved at start initially works. Okay, so it works for the two values we've got. Now we're going to assume there exists a k such that u to the k equals 3 to the k, take away 2 to the k. Now clearly we know there's a k because k is 1 and k is 2 works, but we're now going to show that it also works for uk plus 1. Okay, so assume k such that that is true and uk plus 1 is also true. Okay, we need two starting values, which is quite unusual in these induction questions. So assuming there's a k such that these two work, right? And we know there is. We know there's a k equals 1. Because 1 and 1 plus 1, they work. Now uk plus 2, we're told by the iterative formula at the top is 5 uk plus 1, take away 6 uk. We're told that's the connection, that's the way of generating the next term. Okay, so it's 5 times 3 to the k plus 1, take away 2 to the k plus 1, take away 6 lots of 3 to the k, take away 2 to the k, which is 5 lots of 3 to the k plus 1, take away 2 to the k plus 1, take away 2 times 3 times 3 to the k, take away 3 times 2 times 2 to the k. Okay, I'll split the 6 into 3 times 2, which is 5 lots of 3 to the k plus 1, take away 2 lots of 3 to the k plus 1. Let's do one more step. Two lots of 3 to the k plus 1, take away 3 lots of 2 to the k plus 1. 5 lots of 3, take away, so it's 3 lots of 3 to the k plus 1, take away, I've got minus 5 lots of that, take away another 3 lots of that, there's 2 lots of that. Okay, so I've made a mistake, so this should be minus 6 times that should be a plus here. That should be a plus, which then makes that correct. Minus 5 lots plus 3 lots is minus 2 lots. So it's 3 to the k plus 2, take away 2 to the k plus 2. So u to the k plus 2. Okay, which fits the model we're trying to prove, fits this over here. So u to the k plus 2 we've shown is 3 to the k plus 2 to the k plus 2. I knew I'd gone wrong here because I had in mind what answer I was aiming for. Okay, this is a plus. So plus. Okay, so therefore true for n equals k plus true. Then we need a concluding statement. Since it is true for n equals 1 and n equals 2, and if it is true for n equals k and n equals k plus 1, it is true for n equals k plus 2, implies it is true for all n greater than or equal to 1. Okay, so we've shown it's true for 1 and 2. We've also shown if it's true for 2 consecutive, it's true for the next one. Therefore, by induction, we can show it's true for all values of n greater than or equal to 1. It's that wording is quite awkward at the end.